Hi, everybody. I want to start off briefly on a personal note, just to say how absolutely thrilled I am to be here today. I attended React Amsterdam for the first time last year as a volunteer, so I was really excited to get invited back, and this time I get to be on stage. So my talk today is about a mobile app architecture, which is definitely what everybody wanted to hear at the end of a long conference day. But I promise I'll try and take it easy on you. So first, let me tell you a little bit about myself. As I mentioned, my name is Adam Terlson. I was born in Minnesota in the US. It's okay if you don't know where it is. Minnesota is one of those states in the middle that no one's ever heard of. But I'm coming today from Munich, Germany. You can find me online at Adam Terlson, but to be honest, I'm more of a social media lurker. But I do share my work occasionally. If you haven't come across it already, you might remember in 2016 when Dan Abramov agreed with most of what I wrote in a Medium article. Not that I think about it all the time or anything. So a quick poll of my audience. How many of you would say that you're coming from a native development background? Okay, so maybe 30%. And how many from the web? Yeah, the majority. Well, that last group, I'm with you as well. And yet here I am talking about a mobile app architecture. Well, what am I doing here when my background is in fact not in mobile app development? It's on the web, as I mentioned, and I definitely wouldn't consider myself an architect. So needless to say, my imposter syndrome is on overdrive right now. But while I don't consider myself an architect, I do consider myself an engineer. And I think it's important for engineers to share their stories. What problems did they face and what solutions did they come up with? So that is what I'm going to do today, and I leave it to your better judgment on whether this is something that you might actually consider. So the story begins at my current place of work, a company called Internations. Internations was founded in 2007, and it's the world's largest social network for expats. We have about 3 million users and communities in 420 different cities around the world. We employ around 150 people. So all of this is to say that the story doesn't take place at a company the scale of Facebook or Airbnb, but we're not a small startup either. We've been around for a while. So Internation said that it wanted to build a new native app. Okay, no problem, we can go about doing that. But then they added something interesting. They said that they wanted to replace the old ones. Now this makes things more difficult, because this is what is called a legacy migration. But what does it actually mean to call something legacy? Despite what most people seem to think, it doesn't mean that you don't have to care about this code anymore. In fact, almost by definition, it means the complete opposite. Legacy software plays a vital role both to the business and to the users. And in fact, every engineer hopes that one day his or her code lives long enough to one day be called legacy. So what does legacy look like at Internations then? Well, we have apps on both iOS and Android that were launched in 2015, and they use a mixture of Objective-C and Java and hybrid technologies. But really, these apps had undergone few iterations in that time due to their native technology stack being unfamiliar to Internation's team of web developers. So these apps had some bad ratings and some tough reviews, but thankfully they enjoyed lots of users. What these apps perhaps lacked in quality, they definitely made up for in quantity of features. So Internations is a large social network, so we're talking features like messaging, events, live feeds, user-generated content, photos and galleries, and more. So this is to say that when Internations decided that it wanted to build a new app, it was looking at a rather long road ahead. Undeterred, though, our mission was to build a new app and to be as user and data-driven about that process as possible. Once complete, we wanted to migrate all of our old app's users over to the new before ultimately deleting the old apps. And hopefully, in the process, we would manage to not kill the business. So in other words, ship fast, don't break stuff. So what are some ways that we could have used to migrate? Well, the easiest would have been to just simply deploy our new app into the store overnight for everybody. While this has the advantage of being cheap and will definitely get a high amount of feedback, that feedback will be mostly negative, and the risk to the business is incredibly high. So this is why stores provide beta programs and other services as well, so that you can give early access to some of your users. These beta programs aren't perfect, however. They have their own scaling challenges. So there's still some costs involved going that route. We could have also put apps in parallel into the stores and then simply used marketing or eventually force our users to switch, but there's some limitations around obtaining early feedback. So what we wanted was something that actually combined the best of all three. Something where we can mitigate our business risk, get early feedback of high quality cheaply. So what if looking at this migration as taking place in a single step, we were to break it down into many smaller ones? Now this picture starts to remind me of something from my web development background, which is the migration from a monolith into microservices. Now this can be a very challenging migration, but thankfully there's several established patterns for achieving it. One such pattern is called the Strangler architecture. The Strangler architecture was described in a blog article by Martin Fowler in 2004 as one in which you're able to create a new system around the edges of the old and let it grow slowly until the old system is strangled. Now this sounds ideal for us because you're able to gradually migrate over time. By the way, the name Strangler comes from strangling vines that Martin observed on a tree. So what steps do you have to go through then to implement the Strangler? Well, it's typically just broken down into three. The first is to create the new service. So in the case of migrating from a monolith into microservices, you simply have to pick the first service that you'd like to build. So for example, perhaps we want to build a new registration service. The second step is to actually transparently proxy requests. So you need to capture your incoming HTTP requests, so for example, post requests to API users, and pass that through some sort of load balancer. This load balancer, in terms of the Strangler architecture, is referred to as a facade. So when I say facade, just think load balancer. And this load balancer will, in the beginning, pass 100% of the traffic through to the monolith. Now, the point is that at this stage, the user shouldn't be able to detect that anything has actually changed. But from a technical perspective, what we've achieved is establishing a point of control. Because now in that facade, we can start directing some of that traffic over to the new service. So the effect is that early in your migration, most of the requests continue to be directed to the monolith, with only a small amount going to your modern app. But as your migration continues, this balance starts to change, until ultimately, at the end of your migration, the only thing that you're left with is your modern application. So I'm 8 minutes into this talk, and so far I've only been talking about the web. So how do we apply this to React Native? Well, a direct translation of the diagrams that I showed previously might look something like this, where we need to find some sort of event in our system and pass it into a facade. Then that facade will direct that event either to our greenfield React Native project or to the legacy app. And then this picture repeats itself once for iOS and once for Android. There's a couple problems with this picture, however. The first are these requests. So in a mobile app, we're not talking about incoming HTTP traffic that we can easily direct, so we need to do something there. The second issue is that it seems that there are, in fact, two React Native applications at play, but we all know that that's not the case because React Native is cross-platform. So a different perspective that I came up with is something like this, where we need to establish some sort of event that takes place inside of our iOS and Android applications and pass this into a facade. This facade will then decide whether it wants to execute the original legacy code that would have been executed if the facade weren't there, or to direct this request to React Native. Now, this is what I like to refer to as the React Native double kill, because think about what we're actually trying to achieve. We're not just replacing one application with another. We're actually simultaneously deprecating two mobile applications with a single React Native app, and that's pretty cool. Boom. So what then are the 3 steps to strangle mobile legacy with React Native? Well, first, the obligatory disclaimer. Concepts are more important than specifics here. The reality is that there's many different ways to go about achieving this, and I'm showing only one. So as I show the code, just pay attention to what I say and what I'm trying to achieve, rather than focusing on the actual lines of code. That having been said, the code that I show is only in Swift. If I tried to show this on Java and Objective-C and everything else, this simply wouldn't be a half-an-hour talk anymore. That having been said, the concepts will directly apply on both platforms easily. So step 1, we need to build our new service. So an application can be seen as being broken down into many different parts. And these parts are basically logical groupings of your application's features and screens. In Strangler terms, these parts are referred to as assets. So we need to start by picking the asset that we wish to build first. Often in a Strangler, you will begin by starting with the simplest asset, but it might be the one that's most opportunistic. So in the case of internations, we started with messaging. Uniquely, great advantages to be had by building this natively, and we knew that it was going to serve as the core of our application going forward. So next, you need to actually establish your code base. Now, ideally, we'd be able to run React Native init to set up our greenfield application without touching our legacy app and somehow direct the user to use one or the other. But this is obviously technically impossible, so we have to share the same code base with our legacy. Now, whenever this is the case, it's a great idea to establish a hard separation between the two worlds. So one cool thing that you can do on iOS is to create a shared workspace. So next, you actually convert your entire legacy application into a framework and add that framework as a dependency to your new Greenfield React Native project. Now, the advantage here is that you're able to continue to execute code and access resources from your framework, but note that the opposite direction is not possible. And this is a great limitation because it'll help prevent the spaghettification of your code base. In the worst case, however, you can just start shoving some code around and then apply good engineering discipline to help keep these two worlds apart. When the user actually launches the app, we need them to not even know that anything has changed. So we need to start by actually showing the legacy application as before when the app begins. We can do that by extending our legacy framework's app delegate and overriding the application did finish launching with options function. In this function, we're going to check whether we're in development mode. And if we aren't, they're going to see the original legacy application. But if they are, we're going to go on to initialize React Native. Now, this allows your developers to actually build with React Native in the greenfield. So over time, you come up with something that you actually want to start showing to users. So in the case of internations, again, a new messaging service. So how do we go about actually showing this to people? Well, step 2, we need to start by transparently proxying requests. So returning to our diagram from before, we need to find some sort of event in our system and pass that into a facade. This facade will then immediately invoke the original legacy implementation. So what sort of events are available then for capture in our mobile app? Well, in an ideal world, every event would be something global, but in real life, nothing can ever be so easy. So instead, you can find your events in routing and navigation, user input, push and local notification, your app's lifecycle. Really anything could be converted into an event for capture. In the case of internations, we are interested in the event that occurred when the user pressed on this button to see their messages. So looking at the original implementation and the controller responsible for that event then, we're faced with a couple questions. First, where is the actual event here that we can capture? Second, given the limitations that I mentioned previously, how do we actually execute any code in the greenfield, as I mentioned? So what we can do is be a little creative, and we can actually create our own event. So this is just wrapping the original legacy implementation in a callback. And we're going to provide that callback along with an event that we're going to dispatch. Now this dispatch can be observed from our facade. And when the facade grabs the event, first it's going to check to make sure that that the object passed along is a valid callback, and then it'll just execute it immediately. Now again, this might seem a little silly. At this point, the actual purpose is that the user shouldn't even know that anything has changed. But what we've done is we've established our point of control, because the facade is the space where we're going to start dynamically directing those requests differently in the future. So one tip at this point, if you were to try and go down this road, you should really keep these facades as consistent as possible. So you have to implement every facade twice, once for iOS and once for Android. So the more their implementation can be kept consistent, the easier and less difficult to understand your migration will be. So step 3, we need to start actually directing some traffic to our new service. Returning to our diagram once again, some of our users will head down to the left and see the old messaging system, while some users will go to the right to use the new greenfield app. So how do you actually go about deciding which path the user should go down? Well, you could ask them or have them sign up for some sort of beta program. And from your facade, you could ask the user which direction they'd like to go. Another option would be to control this entirely on the back end and force the event down one path or another. This is actually what we do at Internations. Whichever route you go down, though, the point here is to actually measure the real-world performance difference between your two applications, right? So you can actually measure the performance of your new app with real users. So in this way, you're able to actually scale your application as you become more confident in your feature as you measure. So looking back at our facade then, we need to update our implementation a little bit so that we're no longer immediately executing the legacy behavior. Instead, we're going to check to see if the new React Native app is capable of handling this event. If it is, we're going to launch React Native with some initial properties. In this case, we're just going to tell React Native what the initial route is that it should display upon startup. Launching React Native is rather straightforward, and in fact, this code is taken basically from React Native init. But you need to construct your view controller and your view, and then set that view controller to be the root view controller on your UI window before making it key invisible. Now the effect here is that, ideally, your React Native app is instantly displayed for the users. I say ideally. And then we're going to go on to do one more thing. We're going to set a little bit in the facade which says that the React Native application is running. Now this will come in handy when a push notification occurs. So consider what should happen in this case. Which application is responsible for displaying the in-app push notification, and which application is responsible for what happens when the user taps on it? Well, this is a highly dynamic question. And this is one of the main complications with the Strangler. It's never sufficient to just capture one event. You actually need to capture all events that are necessary for your asset. So in the simple example of messaging, push notifications. So how do we go about capturing these? Well, we can actually just repeat exactly what we did before. We go to the point in our legacy code responsible for handling this push notification event, and we just wrap the whole thing in a callback. Then we send that callback along via a global event dispatch so that we can pick it up later. Now, the difference this time is that the application is already running. The greenfield application is already running, I mean, so we need a way to actually communicate with the app. React Native provides one for us. It's called the RCT event emitter, and it's very simple to use. Simply extend from it, and then you want to override the supported events to tell React Native which events your emitter will be emitting, and tell it whether you want this emitter to start up with the React Native bridge. Once you register your headers, you can import this thing from JavaScript and construct it. Once constructed, you add your listener. So now you have a callback, excuse me, now you have a callback that'll be executed in JavaScript every time the push notification occurs. So now we're able to handle push notifications in our new greenfield app. How do we start directing these requests? Well, once again, the work is in the facade. So we update our facade once more, such that now we need to check whether our greenfield application is capable of handling the messaging, and that the application is running, and that we have an event emitter. And when all of these are true, we're going to send this push notification event to our React Native app. So with this, we've completed the implementation of our Strangler architecture. So we're strangling the views and all of the events necessary for them. At this point, the only thing left to do is to scale, measure, and iterate. So scale, you're going to keep increasing the number of requests that get directed to your new application. Measure, you're going to keep directly comparing the real-life performance in your app. And then you're going to iterate based on that feedback when necessary. So eventually, at the end of this process, you're going to reach 100%. Yay, let's have a party. Like every party, though, there's some mess to clean up. But thankfully, it's rather straightforward, because you've essentially wrapped all of the code that you want to delete in a callback. So you can just go through and delete all of that. Next, you can dismantle the facade and then move whatever event sources that you wish to retain over to the greenfield for maintenance going forward. So at the end of this, you just need to repeat steps 1 through 3 for all of the remaining assets in your application. So 1 down, 100 more to go. So around this time, maybe once you've strangled a couple different assets, or maybe you have simultaneous strangles going on at once, some random stuff kind of starts happening in your application that no one can really explain. So if you have any energy left and you want to try and follow along with me, I'll explain to you what happened to us. But just understand that what I'm about to describe took us over a month to identify and fix. So what happened is that when the Android application was running in the background, a user could receive a push notification. This push notification would get directed to our React Native application, which responded by firing a tracking call. We use OAuth authentication, so in the case that the user's access token had expired, it would successfully complete a token refresh using its refresh token and store the new tokens into state. When the user came back to the app, however, they would eventually see the legacy app, and the legacy app didn't store its tokens in the same place, so it too had to perform a token refresh. except this time when it performed that refresh, its refresh token had expired due to the previously successful one that occurred in JavaScript, and the user would get logged out. So that brings me to step number 4, add more telemetry. You can never have enough telemetry if you're going to attempt something like this. Consider what it took us to actually identify that issue I mentioned previously. We had to track every screen that the user went to and every single API call that they made. We then had to correlate those across user and across sessions. So, add more telemetry. We actually switched from App Center to Bugsnag because Bugsnag has a really cool feature called breadcrumbs, and you can literally leave a trail of markers where everywhere the user went, and this can really be a lot of help for debugging these sorts of issues. So at this point, then, you might be asking yourself, is this really a good idea? Well, I think it depends a little bit on who you ask. If you ask the business, there's more coordination and a higher demand on your analytics. But on the positive side, you're able to get some early user feedback, be data-driven, you've mitigated your business risk, and really this is a migration that you can stop at any time. If you ask the engineer, the world is looking a little more grim. You have the initial setup cost. You still need to understand the native side of things. There's more complexity, which means more bugs. There's a larger app download size, so consider that all of the users who would never actually see your new greenfield project still have to download it. And it can be hard to reach 100%. On the plus side, though, it does keep life interesting, and that's not a benefit to be understated. But in addition, you do get some early technical feedback. So then, has Internations actually accomplished its mission? Well, let's recap. So the mission was to build a new app, and I definitely say that we were successful there. We are able to be user and data-driven about it, but unfortunately, we've yet to migrate all of our legacy apps users due to some missing use cases in the new app. So therefore, we haven't been able to actually delete our new apps entirely yet, but on the plus side, we haven't yet managed to kill the business. So I've glossed over a lot of technical details. So if you want to learn more or see more details in the code examples that I presented today, you can check out the React Native Strangler example on my GitHub. Big thanks to Marcus Osterberg for pairing with me in the development of this project. So, if you'd like to talk about how this might look on Android, or to share your own rollout story, I really encourage you to reach out. I might be a social media lurker, but I'll always reply. So thank you very much, and I hope you enjoyed this talk.